So grade 12, we're starting with our first Loci Cam drawing, and this is cam number 1. So what is given to us is the detail of the roller follower, and I'm going to underline roller follower, and I want to take you down to the actual roller follower that you've seen. So we were previously exposed to sort of a wedge-ended follower, which was done in grade 11, but now we are busy with a wheel that's attached to this follower. So the first instruction is going to be to take all this information which you have here, the thickness of it, which is 8, the height of the follower, which is 60 from the center to the top, and the actual wheel that has a diameter of 16, is to basically redraw this as your starting point and your step 1 in your completion of the cam drawing. So what you are going to do is basically to find the center of the page and to move slightly off center, which I'm going to show you exactly where to start. And to give it a broad explanation, I'm also going to just sketch it for you, and then I'm going to do it with drawing equipment. So as I mentioned, this is your half vertically, and then this is your half horizontally. So basically I'm going to take that information and start around about here, which I'm going to draw my circle, which is 16 diameter in my center, and then I'm going to draw basically a line in the middle here and measure off 4 and 4 on both sides, which is going to be like that there, and then I'm going to put that semicircle in there and cut that off at 60, and then I'm going to darken that completely like that, and that's my first part which I'm going to draw around that sort of center which we have there. So if you can draw that as step 1, let's do that first. Now we're going to look at the specifications, and they ask that the minimum distance from the center of the cam shaft to the cam profile should be 20 millimeters. The cam shaft itself must be 20 millimeters in diameter, and the rotation will be clockwise. So basically what that means, the minimum distance, so if you go over to your sketch, from this bottom part of the roller follower, you are going to measure down 20 millimeters, and then of course that point is where you're going to create your entire center, and everything is going to revolve around that specific point over there. And then you will take your compass from this point to that point and draw this minimum radius that you will see there, which is the minimum distance, radius of 20, but that would be 40 in total for your diameter. And then of course they speak about a cam shaft itself, and the cam shaft itself should be 20, so you're going to measure up 10, or you're going to take your circle template of 20 diameter to draw the cam shaft, and then you're going to hatch that part over there to indicate that that is the cam shaft. Let us do that quickly. So step 3 is where we are going to be working on our cam displacement graph, and we go directly to the instructions where it says that you need to have a horizontal scale which is along this side of 30 degrees equals to 8 millimeters. That's very important, and your vertical scale is going to be 1:1. You need to label your displacement graph and include the scale. That's very important below the graph. And then you need to draw to scale 1:1 the given roller follower in the correct position, which we've done already. So basic explanation, if you go back to your sketch, I'm going to draw a line which basically will derive from this center point here, which is going to form my base of my cam displacement graph. Previously we used to have the line drawn from the tip of the wedge-ended follower, but in this case it is going to be the center of the roller follower, where that becomes the base of your cam displacement graph. You're going to take it as far as possible close to the instructions, and then you're going to draw a line up which is basically perpendicular to this line, and that point there is going to be your 360 degrees. And then you're going to measure from here 8 millimeters, because that's going to be your distance for 12 points on your displacement graph. I normally measure 1 point, and then I take my compass and open it up at 8, and I will have the respective points cut off on here. And there will be a number of points which I will have on here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There should be 12 gaps, and then I will project all my lines up like that there, vertically up, and then I'm going to label it 0, 30, 60 and so on until I get to 360, and below that I'm going to print cam displacement graph, and I will have the scale as well of 30 degrees equals to 8 millimeters. So that's what I'm basically going to do with step 3. So step 4, grade 12, is where we are going to plot the graph using the motion bulleted points here. And it says here that the cam disc rotates at constant velocity, imparting the following uniform motion. Now, very important, uniform motion means absolute straight lines, as you will see unfold in this graph. If you look at the first bullet, over the first 60 degrees, the follower is at a rest. So 30, 60, that means it starts here. You're going to draw a dark line from there to there. There's no movement up or down, it rests. Over the next 60, which is from 60, 90, 120, that the follower rises to a height of 57. So for these two, it rises to 57. So you're going to measure up here 57. So for example, 57 is there. And it will jump up from this point right till there, which is the 57 point on that 120 degrees. Then it says further, bullet point number 3, there is a dwell period for 45. Now the dwell period means it's going to go straight, so it's 30 and half of this is going to be 45, in between 150 and 180 degrees. So you've got to mark it perfectly in half, which is going to be 4, because the entire block is 8 here. So it dwells still there. And then bulleted point number 4, over the next 45 the follower falls by 20, so it's going to go 15 plus 30, that's going to give us 45. The follower will drop by 20, so you're going to measure down 20, that's going to be your 20 over there. You will drop. The next bulleted point, there is a dwell period for the next 60, so it's 30 and another 30, which gives you 60. No movement at all, it goes straight. And the final bulleted point says over the final 90, 30, 60, 90, the follower returns to its original position, which is there, meaning that 360 and 0 would be the same point. So it goes down straight until that point there. And that is what I'm going to do in step 4, using my t-square and my set square and all my dimensions that's given. Step number 5, learners. I've constructed my cam displacement diagram, so I'm going to set up the construction for my cam profile, where my cam profile will be constructed from the information that I have here in my cam displacement diagram. So the first thing that I'm going to do, if I must sketch it, is I'm going to have a maximum radius. So from this point I'm going to project over with my t-square, and then I'm going to take my compass from here to there and draw a maximum radius which is going to look like that. And then I'm going to use my 30 and my 60 degrees because I've already created my quarters here. I'm going to draw 60 degree lines and 30 degree lines through the center point like that there, so that I have 12 spaces here which be similar to the linear 12 spaces that I have here on this cam displacement diagram. Then of course this is going to go in a clockwise direction. Once I have all my lines divided through the center point, I'm going to label each one of these points like I've labeled that there. Keep in mind, if your rotation is clockwise, you start labeling anti-clockwise. So that's going to be 0 and 360, and then this way around is going to be 30, 60, 90, 120, 150, 180, 210, 240, 270. That's going to be 300, and 330 is going to be there, and ending off with 360. So let's set that up quickly. We're looking at step 6 during our cam profile construction. We're going to identify all these spots that are on our degree lines, and I'm going to highlight them in a specific color, which is red. All of these points on the degree lines. Remember, there's an intermediate point here as well between 150 and 180. So we're going to identify all those points clearly. So what we are going to do is we are going to transfer those points on here and use our compass from the center point to transfer that onto the respective points, which is going to be there and there. So that's going to be the 2 points, 0, 30 and 60. And then we're going to bring that across, and we're going to transfer that onto this 90 point, which is there. And then we're going to transfer that way on the outside to the 120 point. Then there's a 150 point on the same line. And then in the middle here, how are we going to get the middle? You're going to take your compass and you're going to arc like that, and get the center here and draw a line through that center. And that is going to be 165, which you are going to have right there as well, 165. And then of course we're going to drop down like that to 180, which you are going to bring to that point over there. And so you're going to follow all the points and transfer them from the center onto the respective point corresponding with the degrees that you have in your linear cam displacement diagram. Let's do this and watch carefully how it's done. And the final step in the completion of the cam drawing, we will take our circle template, and this circle will be drawn around each of those reflecting the roller follower going right around. So we're going to have that 16 diameter circles nicely centered around each of the points, from 0 to 360, as well as the intermediate point. And then of course we will use our pencil just to draw a line freehand, touching the bottom part of your circle, basically forming the cam profile. Watch carefully how it's done. That, my dear boys and girls, completes the cam drawing 1, consisting of your cam displacement graph with a scale of 30 equals to 8 millimeters, and then converted to a cam profile which basically has been highlighted like that.